Hey guys, Matt here. Today we're looking at Leetcode problem 133, clone graph. So the problem description states, given a reference of a node in a connected undirected graph, return a deep copy or a clone of the graph. So we can skip all this nonsense here and look at these examples that Leetcode provides. So in the first example, we are not allowed to do this because this is just returning the exact same graph that we were given. The third example also doesn't work because you can see here the 1 is connected to the 3 and the 4 when it should be connected to the 2 and the 4. The center one is what we're aiming at, and these are entirely new objects. So they still have the same value here. You can see the value, but these are entirely new objects, and that's what makes this a deep copy. So let's look at another example. Okay, so the general plan for solving this problem is to create a dictionary where the keys are the old nodes and the values are the new nodes that we're creating, so the new objects, and they will hold the exact same value. So first we need to populate the dictionary with a depth first search implementation. We will then go back through connect the neighbors, and then all we will need to do is return the start, so the new object that starts the graph, and this will complete the problem. So let's take a look at this example. We are given node 1, so we add it to our stack. We're going to pop this node and map it in our dictionary to the same value, but this is now a new object. So now we will see if 1 has any neighbors. It does, it has 2, so we will add 2 to the stack. That is its only neighbor, so we will pop 2. We will then add 2 to the dictionary, map it to itself, see if 2 has any neighbors. It does, 3 and 4. So we will add 3 and 4 to the stack. Pop 3, see if 3 has any neighbors. It does, but we've already seen 2, so we're going to move on. Pop 4, does 4 have any new neighbors? It does not, it has 2, but we've already seen 2. So we go through and map these to themselves. And this is the general way that we are going to populate this dictionary. You can see that we've used depth first search, and we now have all of the nodes mapped to new objects with the exact same value. Now all that's left is to connect the neighbors. So connecting the neighbors is actually far easier than it might seem. All we have to do is iterate through each key value pair and then look at the neighbors for the old object, find all of them, and add the new objects to the new objects neighbor list. This might sound confusing, but it will make more sense while coding. So to start the coding, I'm going to check an edge case and make sure that this node is actually a node. So we can say if not node. We can just return none, because then we know we're done if we don't have an actual node to work with. Now instantiating some variables, I'm going to set start equal to the node we are given. I'll name our stack and make it a list with the start variable in it. And then I'm going to create a hash map with the name of old to new. So that's going to be our dictionary. So the next step is populating our dictionary with the old objects as the keys and the new objects which we will create as the values. So remember, we're doing this with depth first search. So I'll say well stack. I'll set the current variable to the node that we are popping off of the stack. And then we want to map that old object to the new one, which we'll be creating. So we can say old to new and set that equal to the new object of the node class. And we want the value to be the same. So we can say val equals cur.val. And now we need to loop through all of the neighbors in current and add that to the stack if it's not already in the keys of the old to new. So we can say for neighbor in cur.neighbors. So here we're looping through the neighbors and checking if it's not in the keys. So basically if we haven't seen them yet. And if we haven't, then we're going to put them in the stack so that we can keep the depth first search working. So this will allow us to loop through all of the elements in the node and populate the dictionary with everything we need. So now we want to iterate through the keys and the values and map the corresponding neighbors to the right objects. So we can say for key val in, and then we have to say old to new dot items because we have to unpack these two. And we'll say, and we also have to loop through the keys neighbors. So we'll say for neighbor in key dot neighbors. So we're looping through this list. And now we have to map the new objects and add them to the neighbors of the val, because the val is the new object, and we need the neighbors to be corresponded to the new objects. So we can say val.neighbors.append. So we're adding to this object's neighbors list. And what are we appending? Well, we're appending the new neighbors, which we already have access to through our hash map. So we can say old to new, and we just have to say neighbor. And this will link all of the neighbors accordingly. So now all we have to do is just return old to new with the start. Because remember, the keys are the old objects and the values are the new objects. So we already saved the start. This was the initial node we were given. We saved this in start. So if we get the value, that's just going to be the start to the new graph. So we'll see if this works. Yep. So now let's submit this. There we go. So you can see this is fairly efficient. Beats 58% of users, and the memory beats 56% of users. Thanks, and I hope this was helpful.